The one-sample t-test. Does an 8-battery sample show the mean differs from 10 hours? A one-sample t-test evaluates whether the mean of one numerical population differs from a specified value when the population standard deviation is unknown and estimated from the sample. It answers a question about a mean, not about the probability that the null hypothesis is true. The procedure is most defensible with independent observations and an approximately normal population, especially when the sample is small or contains influential values. The statistic t equals x bar minus mu naught divided by s divided by square root of n uses the estimated standard error of the sample mean. Under an independent normal sample and h naught, it follows a student t distribution with n-1 degrees of freedom. The t distribution has heavier tails than the standard normal because s is uncertain. At small degrees of freedom, a given standardized difference produces a larger p-value than a z reference. As n grows, the t distribution approaches normal. The p-value is calculated in the pre-specified tail area under h naught. It measures compatibility between data and the complete null model. It does not give the probability of h naught. The probability results arose by chance or the size of the effect. Use the test for one sample of quantitative observations and a pre-specified comparison, mean mu naught. The observations should represent independent experimental units or a sampling design whose dependence has already been handled. Report t with n-1 degrees of freedom and the p-value. The sign shows whether x bar is above or below mu naught under the subtraction order. The magnitude expresses the difference in estimated standard error units. Rejecting h naught means the result crosses the selected alpha threshold under the assumptions. Failing to reject means evidence is insufficient for the alternative, not that equivalence has been established. Equivalence requires margins and a different testing framework. A lab records independent battery lives of 9.8, 10.4, 10.1, 9.9, 10.6, 10.2, 9.7, and 10.3 hours. Before testing, it defines h naught, mu equals 10 hours, against a two-sided alternative at alpha equals 0.05. The population's standard deviation is not known. Enter the 8 observations, set population mean to 10, and choose two-tailed. The calculator obtains x bar equals 10.125 hours, s approximately 0.311 hours, and standard error s divided by square root of 8 approximately 0.11. The difference, 10.125 minus 10, divided by 0.11, gives t approximately 1.14 with 7 degrees of freedom. The two-sided p-value is approximately 0.292. So this sample does not cross the planned rejection threshold. Check the raw values for collection order, unusual measurements, and independence. The narrow numerical range supports the arithmetic, but it does not by itself prove random sampling or population normality. At the 5% level, the sample does not provide sufficient evidence that mean battery life differs from 10 hours. The result is compatible with a range of true means and should not be rewritten as the mean. Is 10, the tool does not output a confidence interval, so interval claims require a separate verified calculation. Try it free at distriscope.com.